Okay, so today is 7.2, verifying trigonometric identities. So we're going to talk about what exactly that means and how to manipulate them, and then we'll talk about some examples. So the first thing is that pretty much what this is transforming the expressions on either side of the equation or even the equal sign until both are equal to each other. Things that are important to remember about these, okay? You can manipulate either side or both. There's no rule that you can only do one. You cannot add or subtract quantities from each side. You cannot perform any operation on each side like you would with equations. An unverified identity is not an equation, so the properties of equality do not apply. All right, so pretty much that equal sign is like drawing a line down the middle, and we're trying to balance it to make sure to make them equal at the end, to be the exact same thing, but we aren't actually moving anything across that line. Okay. All right, so these are some suggestions for verifying these trig identities. Once you see what they are, it'll make sense, but I just want to get you all this information before we really get started into it. So some suggestions for verifying them. Number one, transform the more complicated side of the equation into the simpler side. Next suggestion, substitute one or more basic trig identities to simplify expressions. Next, factor or multiply to simplify expressions. Multiply expressions by an expression equal to 1. So sine of x over sine of x equals 1. Express all trig functions in terms of sine and cosine. Okay. All right, so problem number 1. Verify that this is an identity. Okay, so what we're going to do is we're going to work to find ways to pretty much get rid of stuff so that in the end the equal on both sides will be the same. So I'm going to do secant squared of x minus tan of x cotan of x equals tan squared x. All right, so pretty much we could draw an invisible line right here. We aren't moving things on either side of this equation. Okay, the goal is that this side and this side will be equal, but nothing moves. So why not? Let's get a fun color. Okay. Okay, so nothing crosses the pink line. All right, so this side's more complicated. So I'm going to start over here and see if I can start manipulating, moving anything around. So right here I have tangent over x and cotangent over x. So could I replace cotan of x with 1 over tan of x? That was one of our identities. So secant squared of x minus tan of x times 1 over tan of x, okay, because these two are equal. All right, I didn't touch that. Okay, next thing I'm going to do is this and this pretty much cross themselves off. We could this, so that's going to be equal to 1. So I'm going to have secant squared of x minus 1 equals tan squared of x. Okay, so next I'm going to look at my trig identities and see is anything equal to secant squared of x minus 1. If I look back at some of my old notes or a trig identity sheet, I will notice that if I think about squareds, I'm probably thinking Pythagorean. Pythagorean says that tan squared of theta plus 1 equals secant squared of theta. So here, I'll write a side note over here. It says tan squared of x plus 1 equals secant squared of x. Oh, sweet. So I could, for secant squared of x, put in tan squared plus 1, or I could manipulate this and move this 1 and say that tan squared of x equals secant squared x minus 1. Okay. So this is really equal to tan squared of x equals tan squared x. So at this point right here, I have successfully made both sides of my equation equal, and that means my equation has been verified. So these are kind of like proofs, okay? But now we're just doing them with trig. So right here, this is our final statement. That's how we leave it. Our goal is to get there. Okay. Here's another one. Verify that sine A over cosecant A plus this equals this is an identity. This one is just lovely on both sides of our equation. So we're probably going to be manipulating both sides of our equation. Okay? Yeah. I don't want to rewrite this, and so just for memory's sake, well, my beautiful pink pen has gone MIA, so orange it will be. I'm just going to make a line right here just to remind us that we're not moving things to either side. We're just working on this side of orange and this side of orange. So the first thing I'm going to do is I'm going to look at getting rid of these cosecants and secants to see kind of what happens when I do that. So I have sine of A, cosecant is equal to 1 over sine of A plus cosine of A is equal to 1 over cosine of A. All right, I want that to be equal to something over here. I'm going to keep working over here just because I've got this going. So when I have divided by 1 over sine, we can just flip and multiply. So now I'm really going to have sine A plus cosine A cosine A. I'm going to run out of room. So we can simplify that as sine squared A plus cosine squared A. Okay. For now, I'm going to leave it. I'll probably have to figure out what sine squared A plus cosine squared A is, but that's just how I could simplify that side. Let's look at the other side. It's not very pretty. We need it to get somewhere near here. So let's kind of take a look and see what's going on here. Because we have squares, I would guess that maybe we have some sort of Pythagorean identity going on here. Okay. If we take a look at our Pythagorean identities, there is one that relates these two. Okay. It says 1 plus cotangent squared equals cosecant squared. Right? So awesome. So for cosecant squared, let's just plug this into it. Okay? So I'll have 1 plus cotangent squared of A minus cotangent squared of A. And awesome, looks like these two end up canceling each other. So I'm left with a 1. Okay, a 1. So sine squared of A plus cosine squared of A needs to equal 1. So this needs to become a 1. Let's take a look at they're squared, so I'd look at our Pythagorean identities again. One of our Pythagorean identities says that sine squared plus cosine squared is the same as 1. So we can now write 1 equals 1. Done. So remember on the last lesson when I said it might be helpful to write down your identities? This is why. So you're not having to flip back and forth between all of them. Having them in one concise place would be really helpful. I might see if I can find some as well, or finding a good list of them that you can use. All right, let's flip to the next page. 2 more problems. Okay, so this is a problem that is kind of messy. Okay. It says that verify that this mess is equal to this mess and that that is an identity. Okay, so what we're probably going to have to do is, well, we're probably going to have to manipulate both sides. Okay. I'm going to draw a line just so I remember. You don't have to do that every time. It's more just to help you remember as you work your way down. Okay. All right. This has something in the bottom. Well, no, let's not start there. This is secant and cosecant. This is in sine and cosine. So let's change this one to be in terms of sine and cosine to see if that kind of gives us a better direction. So secant is the same as 1 over cosine of theta. And cosecant is 1 over sine of theta. Awesome. Well, these numbers at least match up. Okay. So now at this point, we could let's see. If we notice that the bottom of our equation is sine cosine and they're added together, we probably want to figure out a way that these have common denominators so we can add them together. This is an example of the side that looks the ugliest, maybe the side that we end up making our identity look like. It's kind of an odd one, but it's just the way we work. So we're going to take this and we're going to multiply it by something so that we can end up with sine cosine on the bottom. So that means we need to multiply by sine of theta over sine of theta. And on this one, we're going to need to multiply by cosine of theta over cosine of theta because those both equal 1. Okay. All right, when we simplify, we're going to have 7 sine theta over cosine theta sine theta plus 5 cosine theta over sine theta cosine theta. Okay, so now they're common denominators, so let's add them. So I'll have 7 sine of theta plus 5 cosine theta, which, look, that's the exact same thing as our top, equals sine theta cosine theta. Okay, and then maybe I just bring this down here. I'm honestly okay if you just write an arrow bringing it down if you don't manipulate that side at all. That's fine. So we were able to work through this one side, and it led us all the way over here to this side. Okay, last thing. Techniques used to verify trig identities can also be used to simplify trig equations. So here's an example. Find a numerical value of one trig function of x if cotangent x over cosine of x equals 2. So pretty much we want to manipulate this function so that it's easier for us to solve, right? So what I would do is start out with that cotangent. We know cotangent. We know that tangent is sine over cosine. So we know that cotangent, let's see, cotangent of x equals cosine over sine. Okay, so we can just plug that straight in. Okay. All right, so now this is where I like to write my little thing. So I'm going to have cosine x sine x is equal, or we could do even just multiply 1 over cosine of x. Sweet, these cosines go away, so we have 1 over sine x equals 2. Okay. Or we could say that cosecant of x equals 2. So now we have a numerical value for one trig function. I did not explain that well at the beginning. So find a numerical value of one trig function. When it says one trig function, we are looking at sine, cosine, here I'll write them down, sine, cosine, tangent, cosecant, secant, cotangent. So your goal at the end is to get one of those equal to a number, which is what we did. Okay. All right, your homework assignment is page 434, number 13 to 35 odds. If you have any questions, please feel free to ask. And if not, have fun simplifying trig values.